Hi, it's Maddie. Okay, so in today's lab tutorial, we're going to talk about how to read a Vernier Caliper and how to read a micrometer. Now, the first thing we're going to do is a Vernier Caliper, which is this instrument right here. Now, a Vernier Caliper is great for measuring lengths. Also, really small. The cool thing about a Vernier Caliper is you can do both the inside of an object, so say it's like the diameter of a roll of tape, or you can also do the outside. So in order to do that, what you're going to do is you move this thumb wheel, and you can just move it back and forth. These are called the jaws, and you place your object right between them. Now, if you look here, there are two scales. There's one on the top and one on the bottom. Now, the one on the top is in inches. We don't like inches in this class. We like centimeters. And the one on the bottom is centimeters. That's the one that we want to use. So you're just going to roll it back and forth to where your object is. Let's say that I have an object that is this big. Now, what you're going to do to read this measurement is you want to look through this little window right here. And we're obviously going to be looking at the bottom scale. That's centimeters. So in order to read this, what you want to do is you want to find where the first line lines up with something on the ruler that's above. So in this case, it looks like the first line is right between 2.0 and 2.1. So we're going to write 2.0. What you're going to do is after you find the first line, you want to look for the next line that lines up with one above. Okay, so let's count over. It looks like the fourth line lines up the best. It could be the third or the fifth. If you wrote that, it would be acceptable. But it really does look like the fourth line is right. So in this case, we would do 2.0 plus 0.04. And then your next is just a guess. So there should always be one line on the bottom that lines up with one right above it. And in that case, if it does line up, then your guess should always be 0. In some very rare instance where for some reason you can't find two lines that line up, that's when you can make your guess. But in this case, I'm going to make mine 2.040. And then we always have to include the reading error, which in this case, because we're using centimeters, it's 0.005. Okay, so some other cool features on a Vernier caliper would be this top screw. And what this top screw does is that it can lock your answer into place if you screw it. Say for some reason you had to get up and go to another lab. All you have to do is lock it into place, leave it, and then you can come back and your answer or your measurement is still there. And then another nice thing is these horns at the top. And what these horns allow you to do is measure the diameter of something. So, say for instance, I want to measure the diameter of my ring. All I do is I place it around the Vernier caliper and I spread it apart so that it lines up. And there, that's the diameter of my ring. So let's actually read that. The first big line isn't quite at 1.9 yet. It's still only past 1.8 completely. So our first step is just to write 1.8. Now the next thing we have to do is find out what line on the bottom correlates with the line above. So looking here, I would say the 8th line is probably our best bet. So we would do 1.8 plus 0.08. And then of course, the next step is to make a guess. And in this case, because two lines line up, our guess would be 0. So our answer would be 1.880. Okay, so now that we finished with the Vernier caliper, I'm going to go over how to measure something with a micrometer. Now, the micrometer, first thing you want to know is you always handle it with what's called the cradle, and that's right here. So all you're going to do is hold that with your left hand, and then you're going to use your right hand to actually find the measurements. What you're going to start off doing is you spin this barrel right here, and as you spin the barrel, there's an opening gap that starts to appear. Now, that gap is where you're going to place your object. Now, of course, the more you spin the barrel, the larger it gets. Something that's cool to keep in mind is that, say you have an object and it's here and you need to make it smaller. Instead of turning the barrel, you want to turn the clutch, which is right here. And the clutch is cool because if you keep turning it and turning it, it will stop after a certain pressure point. So if you have an object in there and you keep turning the barrel again and again and again, what's going to happen is it's going to break the instrument and the scale's going to be off and it won't be zeroed anymore. So by turning the clutch, the instrument knows, okay, that's enough pressure, we shouldn't apply anymore, and it stops. So you always want to use the clutch, which is this lined piece right here, when making a measurement. Now, after you have your measurement set, you can use this cool lever, which is going to lock your measurement. So say you had to put this down, go do something, you can easily just flip this switch, lock it, and it'll stay there for you. Okay, so after looking at this instrument, you're going to see that there are two scales. There's the scale on the arm, which is right here, and there's the scale on the barrel, which is over here. Now, the scale on the arm has both hashes on the top and the bottom, and the top is in millimeters and the bottom is in half millimeters. So what that means is it starts off as 0 and then goes 0.5 and then 1, 1.5, 2, 2.5, and all the way through. So the top hashes represent integers and the bottom hashes represent halfway between each integer. So in this case, let's stop it right here. Now, this measures in millimeters. Where we want to look is where the arm meets the barrel. And if we look right there, you can clearly see that 10 is shown. But you also see the hash underneath that, indicating it's at least 10.5. So the first thing we're going to write is 10.5. And then the next thing we have to do is look at the barrel. Now the side of the barrel goes from 0 to 50. So we want to look at where that middle line meets the barrel, and if we look close, it looks like it meets at least at 33. So what we're going to write is 10.5 plus 0.33. Now the last number we have to put down is a guess, which in this case, it's not exactly on the 33 line. So I would say it's about 0.004. So that's what my guess is. So this would come out to be 10.834. Okay, so after you've come up with your measurement, the next thing you want to do is add a reading error, because with every measurement, there's an error. Now, on a micrometer, this is so precise compared to your average ruler. Your reading error on a micrometer is 0.005 millimeters, which in turn is 0.00005 centimeters. And if you want to go one more, it's 0.00005 meters. Now that's really small. If we think about it, that's 5 micrometers, which relates back to the name, a micrometer. So that's why it's called a micrometer, because the reading error is so small that it's 5 micrometers. Okay, let's practice with this example. Right here you see that 10 is shown, so we know it's at least 10. But then you can also see a line indicating that it's 12. So what we're going to write is 12. Now we have to look at the arm to see what's next. Looking at the arm, it looks like the middle line lines up with 26. So we would write 12.0 plus 0.26. And the last thing we have to include is a guess. So in this case, because the line lines up with the one on the barrel, our guess would be 0. So our answer would be 12.260. Okay, and that's how you read a micrometer.